This meeting is being recorded.
In a past video lecture, we've seen how sometimes a compound will contain a chiral center, but nonetheless be achiral. So we've seen some examples of that. And then in this section, 5.9, we're going to see kind of the opposite of that, where we can have a chiral compound without a chiral center. So these specific types of compounds, these are called atropisomers. So this word given down right here. And these are stereoisomers that normally would have that interconversion or be interchangeable through rotation of a sigma bond, right, a single bond. But because they have bulky groups around that sigma bond, they're kind of stuck in one conformation or another. So they can be stuck in different conformations, like this example shown down below, where we have this compound abbreviated BINAP, BINAP, and we have the R and the S conformation because this bond right here that would be thought to be freely rotating because it's a sigma bond is actually stuck in one or the other conformation. So there's not enough energy to form this the in-between compound here, where these two large phenyl ring groups here would be next to one another. So what we see is that we're stuck in the S configuration or the R configuration, and these compounds would then be considered chiral, even though there's no chirality center, right? Both sides of the compounds are the same, so we would not see a chirality center, but they are chiral and enantiomers of one another. Another example of when we might have chirality without a chiral center are compounds called allenes. So these guys here have two carbon-carbon double bonds next to one another. And if we take a look at the p orbital overlap, so the central carbon, it's overlapping on the right here with these p orbitals on the carbon on the right. So this orientation provides these groups over here on the dash and the wedge to kind of be poking out into the back of the page or coming out into the front of the plane of the page here. Whereas on the other side, the central carbon has a p orbital overlap with the left-hand carbon in this orientation. So they're perpendicular to one another. And we would see that these R groups, this side of the compound, would be within the plane of the page. So with allenes, we see that the two ends will be different. So if we were to draw that mirror plane in between them, we would see that they would be non-superimposable mirror images of one another. So again, this is another example of a chiral compound, even though it does not have a chiral center. So it does not have a carbon with 4 different groups. So we'll take a look at the last section from chapter 5 in the next video.